Okay, in this video we want to find a general solution for a higher order differential equation. So we have y raised to the fourth prime minus 8y prime is equal to 0. And so it's a homogeneous equation. So we can say r raised to the fourth minus 8r is equal to 0. We can factor out an r, and so we would get r parentheses r cubed minus 8 is equal to 0. R cubed minus 8 can actually be factored, so we would get r parentheses r minus 2 parentheses r squared plus 2r plus 4 is equal to 0. And so the next thing is we want to know the roots. So what value of r can we get 0? And so right away we know if r is 0, that's gonna work. Also r is equal to 2, that would also work. And we can factor this out, so we have to use a quadratic equation. So we'll say r is equal to minus b, so minus 2, plus or minus the square root of b squared, so 2 squared, so 4, minus 4ac, so 4 times 1 times c, 4, so minus 16, divided by 2a, so a is 1, so divided by 2. And so we would ultimately get, so negative 2 divided by 2 is negative 1, plus or minus, so 4 minus 16 is minus 12. We can break down minus 12 by having a negative 4 times 3, and so we would get plus or minus the square root of 3i. And so these 4 are our roots. So I'm going to scroll down and we will solve this problem. And just to recap, we've discovered our roots were r is equal to 0, r is equal to 2, and r is equal to minus 1 plus or minus the square root of 3i. And so our general solution will be y is equal to c1e raised to 0t, which we know will be c1. So we don't need this because e raised to 0 is simply 1. Plus c2e raised to 2t because of this, plus c3e raised to negative t because of negative 1 here, cosine square root of 3t because we have plus or minus the square root of 3i, plus c4e raised to negative t, sine the square root of 3t, like this. And this is our final answer, and we simply need to box it in. And that's all we need to do.